Now in exercise 7, problem 5 is a 5-part question, and what I'm going to do is the solutions we get for A, I'm going to try and squeeze them up somewhere here, so that we later on going to use those solutions in order to calculate some of the problems. I think it's problem number C, if I'm not mistaken. So in problem A, they say express sin P in terms of H and M. But before we can do that, let's assign the sides as we always do. We're going to, in terms of P, in terms of angle P, this becomes my opposite side, and this becomes my hypotenuse. And later on we're going to talk about R, which is in part B, which is question number B. And for R, same applies. This becomes my opposite side, and this is my hypotenuse. Now this leaves PS as my adjacent, and SR being adjacent, the angle R as well, adjacent angle R. Right. Now let's express sin P in terms of H and M. Now we do know and remember, as always, our SOHCAHTOA acronym. SOHCAHTOA acronym. Now, once we say sine, we're actually going to be talking about opposite over hypotenuse. Now, obviously, the opposite side for P is H, and the M is my hypotenuse. Therefore, the answer to this will be sin P is equals to opposite, which is my QS, over QP, which is actually H over M. So therefore sin P is equals to H over M. So I'm going to write that here. That's for A. We said sin P is equals to H over M. Beautiful. Now we go to part B. B, which says express sin R in terms of what? Of H and N. H and N. R in terms of sin R in terms of H and N. So again, sin R, acronym SOHCAHTOA, opposite over hypotenuse. This is the opposite side, that is going to be sin R is equals to side QS over hypotenuse side being QR, and that being H over N. Therefore, sin R is equals to H over N. And then I'm going to write that here for B. Sin R is equals to H over N. Now I've got two equations given there. I'm going to write this out so we can go to C. C then says, hence show that M sin P is equals to n sin r. Now remember we had those two equations, sin p equals to h over m and sin r equals to h over n. Now they've got a common side, or should I say a common variable, which is h. Now if we say from a sin p equals to h over m, therefore m sin p is equals to h. You see that? Now we go to from b sin r is equals to h over n, therefore n sin r is equals to h. You see, they are both equals to h. Therefore m sin p will be equals to n sin r, both equal h. Okay, you got it. Now part D says we should use what we've just found in number C to calculate the size of angle P. What we've just found here is this. Let me write it here, which is m sin P is equals to n sin r. Okay, now I'm going to rub this off so we can write D. Really should get a bigger board, eh? Alright, that's D. From this information that we've just found on C, where m sin P is equals to n sin r, we are going to calculate the size of P. If now they say m is equals to 40 centimeters, n is equals to 30 centimeters, and r is equals to 80 degrees. You are going to simply substitute that into the equation where you're going to put m as 40, n as 30, r as 80, and then find the angle P. But because before we do that, let's do the subject of the formula for P. So m sin P is equals to n sin r, divide both sides by m, therefore sin P is equals to n sin r over m, and then P will be equals to arc sine of n sin r over m. Beautiful. Therefore P will be equals to arc sine, n being 40 or 30 centimeter, that's going to be 30 sin 80 degrees, all over m is 40 pardon me, it's not 40 degrees, it's 40 centimeters. That's 40 units. Okay, and therefore P will be equals to, you punch that into your calculator, that's going to be sine 30 sine 80 all over 40, and that's going to be equals to 47.6 degrees. So therefore angle P will be equals to 47.6 degrees, and that is your final solution.